Okay, now we discussed this last week, and I can understand if you look at that schedule, okay, Wednesday and Thursday, okay? So Wednesday you are not in here. That is your homecoming activities day. I don't know what you're doing, if it's the hide and seek or... Okay. Okay. So then, yes, what?
Oh, why is the tomorrow blank?
I haven't got to that yet. Okay. So with this, okay, on plan book, I believe it just says maybe work on papers or something to that extent. I can take a look here quick in just a moment. No, tomorrow we might continue. It just says types of forces, because I think there's certain types to go over yet, because it's some of your vocab terms. There's a strong force, there's a weak force, there's an electromagnetic force, and then there's the force of gravity. Okay. So I'll just go ahead and pencil that in. All right. So we'll just say forces in here. Now, what else about this week would you like some clarification on? Because again, when you look at the schedule, okay, your vocab, we're not having a vocab quiz this week, but your terms are still due. No. They're not due today. Okay? But what that means then is the 7th hour class. Okay? No.
Wednesday.
Okay? So then we flip-flop. So that being said, I've got a paper to hand out to you today. And then you have your vocab terms. We'll have that evaluation of vocabulary sometime next week. Okay? So what that means is you have that opportunity to work on those today, and you can work on these papers. Because, as we all know, everyone's busy. We're not going to take anything away from that. You're busy, I'm busy, we're all busy. Okay, so a little bit of context. Okay, a little bit of context that we want to give you here. Weight and force are the same thing, okay? And what we mean by that is it's just different types of measurements, okay? In other words, if you go over to Europe, perhaps, can you spend the U.S. dollar? No. You might be able to, but not likely. Okay? You'd have to have a place that would accept U.S. currency, and I would find it hard to believe that they would. But does that mean that you don't have any money? No. No. You would take your U.S. dollar and do it an exchange rate for, is it the pound or is it the euro? It's actually the euro. Okay? So it's just different types of money that have different types of labels, whether it's the yen in the Oriental Far East, the dollar here, the euro. Maybe some places they still use the pound. I don't know. How many of you are in Spanish? What is it? Is it pesos? Peso. Okay, so you measure currency by pesos. Okay, so that's what we're trying to illustrate, that pounds is English, but technically it's also a force, because a person's weight equals their mass times the acceleration. So, and this acceleration would be due to what, do you think? It has to be between two objects. So for each and every person on Earth, the two objects is you as an individual and the Earth. And it has a gravitational pull to it. So what we mean by that is all throughout the solar system, you would not have the same weight. And one of those problems deals with that, to where on the moon, gravity is 1.67. I think it says newtons per kilogram or something like that, but you could exchange that as 1.67 instead of 9.8. Okay? Does everyone have the stapler? Does everyone have their papers stapled? Okay, well then we need to keep moving then. Okay, thank you. All right, then just leave the stapler there when you're done. Okay, so why is it that people would weigh less on the moon than they do the Earth? Do you know? Yeah, I know it's gravity, but that doesn't explain why they weigh less.
It's the force. It's the force.
But why would there be more force here on Earth than up on the moon?
Closer to the sun.
Well, it's not that it's closer to the sun.
It has a bigger gravitational pull.
Right. The Earth is much, much bigger. So should you be able to survive on different planets, your weight is always going to change. Because it's your specific mass, that will never change. The mass would be however many kilograms here. It would be that many kilograms on the moon, that many kilograms on Jupiter, that many kilograms on the sun, should you be able to survive that, which is, of course, not going to happen. But these problems will get harder and more difficult, as they should. Okay? So what I want you to do is take advantage of some of these opportunities. For instance, go ahead and look at number 11. Okay? It says, what is the mass of a bull during the rodeo? Or it should say maybe during a rodeo. It pins a rider against, it should say gate, okay? As its velocity is 10.25 meters per second, and collides with the cowboy with a momentum of, 10,228.50 kilograms per meter per second. Okay? So then, what do we know in that problem? Okay, so what's that you say momentum, that's fine. Okay, so that's letter P.
Equals 10228.50.
And what's the label for that?
M/seconds. kg/n/.
Okay, so it doesn't necessarily have to say a momentum of this. Because how do we know that this is momentum other than us telling you that it is? Because of the label. What else do we know in this problem?
Velocity is 10.25.
Now, we know it's a velocity because it says moves at, it's got a measurement of meters per second. So it's not an assumption, it's a presumption. Is this the velocity we want and or need? And it is, but why would you know that? What does it say in the problem, in that last line where it says 10.25, then what does it say?
And then it collides with it.
Right, so once there's impact between the animal and the cowboy where it pins them up against the side of the gate or fence or whatever, we know that this is a final velocity. It didn't say anything about anything earlier or move from this speed to this speed. It just has this as a velocity. So what is the question asking then?
What is the mass of the bull?
Okay, so how would we go forward trying to figure out the mass of this animal? Well, I know you're going to figure it out. Where do you see these three variables together? Yeah, I know they're in the problem. Okay. So once you have this, do what the formula tells you to do. Okay? So in any formula, you have an equation. What's on the left-hand side of that equation?
No.
Okay? So then we substitute for what letter P is for, and that's 10228.50. What's on the right-hand side? 10.25 and M. So how are we going to get M all by itself? Okay? So we divide each side by 10.25, so our mass now is what? $997.90 kilograms. Okay? The reason that is significant is because why could you not do number 12 right away? Because it says from the previous question, what is the force exerted on the cowboy? Okay? So, the question's asking for force. So what two things do you need to know to solve for force? Mass and velocity? No. Mass and acceleration. Well, we only have this coming from the previous problem. We have our mass because we just solved for it. But as we read further, what's that force exerted if the bull started from a standstill and ran at the cowboy for 2.45 seconds? Okay? So, we're going to use some of this information along with that. So, for question 13, is that right, or 12? For question 12, what do we know in that? And that's a what? So that is a time. Okay? What else in problem 12 that you need to account for? Yeah, velocity, but we've got a velocity.
Your
Initial velocity.
Right. You need to account for that initial velocity, but should you skip that, is it really that big of a deal? No, it's not. Why would that be? What does it say about this bull? How's he starting?
standstill.
Why is starting from a standstill important?
It's an acceleration.
It has something to do with the acceleration.
Initial velocity.
That is the initial velocity. That's right. So it has an initial velocity then of 0. We've got our mass. We're looking for the force. So how are we going to solve for the acceleration now? So one of the things you have to be telling yourself is the concepts and problem-solving abilities that you learned last chapter, that is going to keep on going all the way through December. You just don't forget how to solve for velocities, accelerations, and all that types of materials. Is that stretching or question?
Question.
Yes.
Can I go to the bathroom?
Yes. Okay. So then the force equals our mass, which we know is 997.90, but we got to have that acceleration. So how are we going to solve for that? Okay. So then we want to solve for our acceleration. And do we need to write the initial velocity in this equation?
No.
The answer would be no. Why would that be?
Because it's nothing.
Because it's 0. So then what goes on the top of this fraction? Yeah, 10.25, because that's how fast it was moving. And then what goes on the bottom then? Time, which is what? Now, if you want to put -0 up here, you can. You can say, I'm accounting for my initial velocity, but it was 0 because it tells you that in the problem. So you technically don't have to write that. So our acceleration now then is what? Okay, so it's 4.18 what though? Okay, then we will leave that up to you to, yes.
Did we do 11?
We did. Okay, and then we'll leave that up to you to finish number 12 because you've got your mass, we've got our acceleration, so now you can find your force. Okay, so we are giving you this time. You either can work on your vocabulary, you can work on these problems, and they are due for this class on the 26th. 26th, however you want to say it. Because on Wednesday, we do not have class in here. Okay. We will catch up to you next time.